So now come to question number 16, exercise 1 of phase 2 ellipse. A circle of radius r is concentric with the, so equation of circle can be written as x square plus y square is equal to r square. So you can consider there is a ellipse and there is a circle somewhere where r must be between a and b. Actually, it must be written r is between a and b. It must be written r is greater than or b less than a, because a is large. So then equation of common tangent, this kind of tangent you want, equation of common tangent. The common tangent is inclined to the major axis at an angle this. So this we have to prove. Or this side, fourth common tangents will be there. So equation of tangent, standard form for this ellipse is y is equal to mx plus minus under root of a square m square plus b square. One I am taking plus one, minus also can come. Slope can be positive, negative, both sides. This kind of tangent or this kind of tangent, four tangents there. Now this is also y is equal to mx plus c. So this is the c part. If the line y is equal to mx plus c is tangent to x square plus y square is equal to r square, then condition is c square is equal to a square r square into 1 plus m square, or distance from center must be equal to radius that we can use. So a square m square plus b square is equal to r square into 1 plus m square is equal to r square plus r square m square. Transfer this side. So m square a square minus r square is equal to r square minus b square. So m is equal to m square is equal to r square minus b square upon a square minus r square under root. So this is a slope. Tan theta is equal to this, so theta is equal to tan inverse of that. So that will be answer. So thank you.